Hello friends, welcome back. Hearty welcome to you. In this session, let us see how to find out domain and range of a function. So we have simple example to start with. So we have to find out the domain and range of function 1 by 4 minus x square. So let me write it. F of x is equal to 1 by 4 minus x square. This is the function for which we have to find out the domain and range. Now let's try to first find out what is the domain of this particular function. We know that domain is all the values which we can supply to x, or the values that can be given to the function such that the function is clearly defined or the function is definable. So 1 by 4 minus x square, it cannot be defined only whenever the denominator, we know that whenever we have numerator by denominator, so the fraction is defined only when the denominator is not equal to 0. Similarly here we have 4 minus x square in the denominator. It cannot be equal to 0. If that is equal to 0, I will have 1 by 0 which is not defined. So the function is not defined. Now what is 4 minus x square? 4 minus x square is in the form of a square minus b square. Can I write it as a minus b into a plus b, that is 2 minus x into 2 plus x, not equal to 0. Whenever two conditions are not equal to 0, both of them independently should not be equal to 0. Therefore x is not equal to 2, x is not equal to 2, and also x is not equal to minus 2. That means whenever x value is 2 or minus 2, the function is not defined. Otherwise the function is properly defined. Therefore the domain is given by r. R is the real values, all the real values other than minus 2 and 2. So this is the domain of the function. Now taking this into consideration, as we know the domain values, let's try to find out the range. We can find out the range in two ways. One way, we can supply the values of x whatever we know from the domain and see how the values of range are changing. Based on that we can find out the range of the function. Or we can also do in another method which we will see just after completing this particular checking by values. So we know that x is not equal to 2 or x is not equal to minus 2. Now other than that, what are the values we have? Let us say suppose x equal to 0. If x equal to 0, y value or function of x, f of x, y value will be how much? Y is equal to 1 by 4. So if x equal to 0, y equal to 1 by 4. If x equal to 1, what happens? If x equal to 1, y will be nothing but equal to 1 by 4 minus 1, which is equal to 1 by 3. So which is equal to 0.33, and here I see the value is 0.25. So when x equal to 0 it is 0.25, x equal to 1 it is 0.33. So you can check for x equal to 1.5 or value which is near to 2 like 1.99. You will see that the values are going on increasing. That means we are going towards infinity values. So we are starting from 1 by 4 and we are going towards infinity. So we know a particular section of the values of the range. Now let us start from x equal to 2 onwards. Let us take x equal to 2.1. If I take x equal to 2.1, y will be 1 by 4 minus 2.1. 4 minus 2.1 whole square. This is in the form of 1 by a square minus b square. So can I say 2 minus 2.1 into 2 plus 2.1, and we see that these values are nothing but negative values. I can see very clearly that's nothing but equal to 0.41. 4.1 into 0.1, that is nothing but 0.41. And the next time if I put suppose x equal to 3, I see that y equal to 1 by 4 minus 9, that's equal to minus of 1 by 5. So you can see that the denominator values are going on increasing. That means the x, whenever I take x values in 2.135 like that, I see that the y values are going on decreasing. That means the y values are going towards minus infinity. Now with this understanding, we can go back and we can give the range. So we know that when I take positive, it should be between 1 by 4 to infinity, and when I take negative, it's between 0 and minus infinity. So club them together, I can give the range as minus infinity to 0. Not included, boundaries are not included, union. Again, you can start from 1 by 4, and 1 by 4 is allowed, so that's a square bracket, comma, infinity. So this is the range of the function. Now instead of checking the values and trying to understand the pattern, is there any other way how I can easily find out the range? So let us look at that other way. The way what we have looked at now is we know the domain values, which took the sample values, and based on that we'll try to understand how the pattern is, that how the values of y are changing and which values are not allowed for y. So we are able to find out that the range is nothing but negative values minus infinity to 0, and after that 1 by 4 to infinity. So any values between 0 to 1 by 4 are not allowed. So can we find out the same thing in another way? So let's do that. For that, what we will do, we'll use a simple logic. The logic is that suppose I have a function which is from set A to set B with the values x from the domain and y in the range. The function is given by x comma y, the values. If the inverse function will have B set as the domain and A set as the codomain, and the values will be starting from y to x, then this function is called as inverse of the original function. Now what we will do is we apply this logic that to find out the range of the original function, can we go ahead and find out the domain of the inverse function? Now how to do that is pretty simple. What we do is we take y equal to 1 by 4 minus x square, and we try to find out the x value from here, and then we switch x to y. We switch x to y so that we can go to the domain of the inverse function, and there we'll find out which values can be given to x. I'll repeat again. We'll take y equal to 1 by 4 minus x square. Let me show it to you. 4 minus x square equal to 1 by y, or can I write down x square equal to 4 minus 1 by y, or x square equal to 4y minus 1 by y, or x is equal to square root of 4y minus 1 by y. This is the original function. If x value is given when you know the y value. So when you go to the inverse function, x will become y and y will become x. So it will be like y equal to square root of 4x minus 1 by x. Now if I am able to understand the values what can be given to the x, that is nothing but the range of the function, nothing but the range of the function 1 by 4 minus x square. So I repeat again, whenever you want to find out the range, you take y equal to f of x, express x in terms of y, after that switch x and y, so x to y and y to x. That means you are going now to the inverse function, and the domain you are going to find out, that's nothing but original function range. So even you don't understand what we are trying to do, just remember that you take y equal to f of x, get your x in terms of y, then switch x and y, then you try to find out what are the values that can be given to x. So now we know that the inverse function is y equal to square root of 4x minus 1 by x. We'll note down here because I'll explain you with one example. We'll take one value and see how these are inverse functions. We'll do that afterwards once we get the range. So I'll write down here y equal to square root of 4x minus 1 by x. Now, for which values of x this particular inverse function is defined, if I am able to understand that that's a domain of the inverse function, which is the range of the original function. So let's go ahead and do that. So inverse function is given by square root of 4x minus 1 by x. Now we know that in square root we can have only positive values. So what are the scenarios when I can have positive values in square root? I can have it in two scenarios. One scenario where 4x minus 1 is greater than or equal to 0 and x is greater than 0. Because you know that x cannot be equal to 0. If x equals to 0, 1 by 0 will be not defined. So denominator should be greater than 0 and the numerator should be greater than or equal to 0. In that particular case, I will get positive value. Is there any other scenario? The other scenario is when both of the values are negative. So 4x minus 1 is less than or equal to 0, or can I say less than 0, and also x is less than 0. In this case, both are negative. Negative by negative will be positive. That is the second scenario where I can get it. Now let us take these two and try to find out how the range will look like. 4x minus 1 is greater than 0. That means 4x is greater than or equal to 1. Or can I say x greater than or equal to 1 by 4, and also x greater than 0. X has to be greater than 0 and x has to be greater than or equal to 1 by 4. That is nothing but it is given by 1 by 4 comma infinity, because x has to be greater than or equal to 1 by 4, which takes care of x greater than 0. X is greater than 0, x also has to be greater than or equal to 1 by 4, both of them to be satisfied. So it will be nothing but 1 by 4 comma infinity, where infinity is not included. Similarly, let's go to the other side. We have 4x less than or equal to 0, or x less than or equal to 1 by 4, and also we have another condition, that is x less than 0. Now let's understand this. X has to be less than 0 and also x less than or equal to 1 by 4. Now which condition you will take? You will take that x less than 0 satisfies both the cases, because if x is less than 0, x is also less than or equal to 1 by 4. So here the scenario will be 0 comma, I can say minus infinity. We start from negative values and we go till 0. So these are the two cases where function is defined properly. That means my answer for this particular function, domain of the inverse function or the range of the original function, is given by minus infinity to 0 union with 1 by 4 comma infinity. So this is how we can find out the range of a function. The logic is very simple. To find out the domain, there are only two constants you have to see. First thing, you have any square roots, then square root inside should be only positive value, or it can be max 0. You have any denominator, if you have denominator some variable values, then that value can never be equal to 0. And if it is square root, then it cannot be equal to 0, or it cannot be less than 0 also. That means it has to be greater than 0. These are the conditions which, if you are able to understand, we can easily find out the domain. Once we are able to understand what is domain, to find out the range, what we do is we take the function y in terms of f of x. We try to find out x in terms of y. That is, then we will switch x and y values so that we can go to the inverse function. For this inverse function, we'll find out the domain. Now that's nothing but equal to range of the original function. So that's how we can find out the range. Now let me take this example of two inverse functions and show you why they are called as inverse functions. Now we know that two functions are called as inverse functions when I have x comma y in the first function and the second function gives me exactly y comma x. So let us check that does it work out here. Y equal to 1 by 4 minus x square, and I have y equal to square root of 4x minus 1. divided by x. Now let's take some x comma y values and try to have the ordered pair there. Suppose I take x equal to 0. If x equal to 0, y equal to 1 by 4. So one pair I can have from this function is 1 by 4 comma 0. Now obviously if this is the inverse function, on the other side I should have 0 comma 1 by 4. Let us check it. If x equal to 0, if x equal to 0, then 4 into 0, that's my bad, I think I did wrong here. If x equal to 0, y equal to 1 by 4, I have proven again one more time that I'm little bit dumb. So let me just go and erase that. Okay, if I take x equal to 0, y equal to 1 by 4. So in the inverse function I should get 1 by 4 comma 0. Let us take x equal to 1 by 4. 4 into 1 by 4 is 1. 1 minus 1 is 0. 0. So you can see that we can check for another value if you want. I will check for 1 by 2. Let us check for 1 by 2. 4 minus 1 by 4. That is nothing but 4 minus 1 by 4 is 15 by 4. And that's nothing but equal to 4 by 15. Okay, now this is the inverse function. If I supply 4 by 15 to that, it should give me back 1 by 2. Let us check that. I will do it for you. I'll write down square root of 4 into 4 by 15 is 16 by 15 minus 1 divided by 4 by 15. If you simplify that, you will get 1 by 15 by 4 by 15. That is 1 by 4. Square root of 1 by 4 is 1 by 2. That's the meaning of, that is the logic behind, that's logic based on which we are going to the inverse function and we are finding out the domain. Now you know that you want to find out the value of 1 by 4 in the range. You go to the inverse function and find out the domain value. That's nothing but equal to range of the original function. So we'll do some more examples on how to find out the domain and range of some simple to intermediate level examples. So I'll catch you once again with another example. We are dealing with sets, relations and functions as part of domain and range of functions. Thanks for your time and support. Bye for now.